Okay guys, today we will tackle about the differential operators. What is differential operators? Differential operators is an operator that denotes differentiation, that is, when applied to a function, a derivative is obtained. So here, if we let D be a differential operator, so for the first, this one, so D subscript of x, which means the first derivative with respect to x. Then the other one, D with superscript 2 and subscript x, which means the second derivative with respect to x. Then the third one, the D with superscript 3 and subscript x, which means the third derivative with respect to x. Then last, D with superscript k and subscript x, which means the kth derivative with respect to x. So then in general, D with superscript k and subscript x, k which means the order of the derivative, and the x which means the independent variable. So here, D with superscript x, D with superscript k and subscript x is normally written as D to the k, which is disregarding the subscript. If no subscript is written, it is understood that it is with respect to the x unless otherwise stated. So here, D with superscript k can be read as D to the k. So the D2, which can be read as D squared, then here is D cubed and D fourth, and so on. But you have to keep in mind that k means order and not exponent. We should also remark that the differential operator is approximately called a derivative operator because it gives a derivative instead of a differential. Okay, here, when we apply to a function y is equals to f of x, we get D with subscript of x followed by y, or also means D followed by y it is equals to derivative of y with respect to x. And here, D subscript to k, D with superscript k and subscript x followed by y, or also means D raised to k followed by y, which is equals to k derivative of y with respect to x, which means that dy is applied by y, and here D with superscript k followed by y, which means D to the k applied to y. So that's it about the concept of differential operators. Okay, now let's solve this some example. So evaluate this given. So here we see that D was multiplied by inverse of tangent x plus ln, then x squared plus 1 plus 3 x squared plus 1 raised to negative 1. So we see that D raised to, see that here we have raised to 1. So we have only one derivation. So first, the derivative of inverse tangent x, it is equals to 1 over 1 plus x squared Then for the ln x squared plus 1, it is equals to 2x over 1 plus x squared. Then for the 3x squared plus 1 raised to negative 1, it is equals to negative 3x squared plus 1 raised to negative 2 multiplied by 2x. So let's combine these two terms. So first two terms, it is equals to 2x plus 1 over 1 plus x squared. Then the second term, two terms, is negative 6x over 1 plus x squared raised to 2. So combining these two fraction, it will, now we will have 2x cubed plus x squared minus 4x plus 1 over 1 plus x squared raised to 2. So that's it. We have now the first derive of these three function. We have 2x cubed plus x squared negative 4x plus 1 over 1 plus x squared raised to 2. So let's solve another problem here. So d cubed e raised to 4x minus cosine 5x plus 8x raised to 7. So we have three derivatives right now. So we have three process. So first, for the first derivative of e raised to 4x equals to 4e raised to 4x. Then for the negative cosine 5x, it was negative 5 sine 5x. Then for the 8x 7 raised to 7, its derivative was positive 14x raised to 6. Then for the second derivative, the derivative of 4e raised to 4x equals to 16e raised to 4x. Then for the negative 5 sine 5x, it was equals to 25 cosine 5x. Then for the 14x raised to 6, its derivative was positive 84x raised to 5. Then we have the last derivative. So derivative of 16e raised to 4x, it is equals to 64e raised to 4x. Then for the 25 cos 5x equals to negative 125 sine of 5x. Then for the 84x raised to 5, it is equals to positive 420x raised to 4. So that's it. We have three derivatives, first one, second, and third. So this is the answer. The third derivative of this function. So let's have last example, d raised to 5. So we see that we have 5 steps to solve this derivative given value. So d5 sine of x minus cosine x plus 3e raised to x plus 5x. So for the first derivative, it is equals to, so this for the derivative of sine of x equals to cosine x, and the negative cosine x equals to positive sine of x. And for the 3e raised to x, it is equals to 3e raised to x. Then for the x raised to 5, its derivative is positive 5x raised to 4. Then the second derivative for the cosine x, derivative is equals to negative sine of x plus, for the positive sign x equals to cosine x. Then the derivatives of 3, so I forget to add here positive sign. So the derivative of 3e raised to x equals to positive 3e raised to x. Then for the 5x raised to 4, its derivative is positive 20x x squared. Nope, it's cube. Then for the third derivative, the derivative of negative sine of x equals to negative cosine x. Then for the positive cosine x, it is equals to negative sine of x. Then for the 3e raised to x equals to positive 3e raised to x. Then for the derivative of 20 x raised to 3 is equals to positive 60 x squared. For the fourth derivative of negative cosine of x equals to sine of x. Then for the negative sine of x equals to negative cosine x. Then for the 3e raised to x, also positive 3e raised to x. Then for the derivative of 60 x raised to 2 equals to positive 120 x. Then now we have the last one, derivation. So derivative of sine of x, it is equals to cosine x. Then for the negative cosine x, it is equals to positive sine of x. Then for the 3e raised to x, it is also 3e raised to x. Then for the 120 x, its derivative is equals to positive 120. So that's it. We finally solve its differential operator. We also note that if we have here based on its exponential value, so 5, so we have 5 derivation, 1 2 3 4, then last. So these are some example about the differential operators. I hope you learned about this topic. Thank you for watching.